Bob, Aviation 360's delay predictor, was built with TensorFlow. Our chatbot uses PyTorch, and our image recognition runs on Keras. Most people think AI just magically appears.
Wait, you're saying different AI systems need completely different development tools. How do you even choose between them?
You're about to discover the powerful development frameworks that make AI possible and why framework choice dramatically impacts testing strategies. Understanding these tools transforms how you evaluate and test intelligent systems. Bob, imagine trying to build our neural network delay predictor by writing every mathematical calculation from scratch. We'd need months just to implement basic matrix multiplication.
That sounds impossibly complex. How do developers actually create AI systems in reasonable timeframes?
That's where AI development frameworks become game changers. But here's the mystery. Why do we use TensorFlow for some systems, PyTorch for others, and Keras for different applications? They all create AI, right?
Good question. Wouldn't one framework handle everything?
The answer reveals why testing strategies must adapt to framework choices. According to ISTQB, AI development frameworks support data preparation, algorithm selection, and model compilation for different processors, CPUs, GPUs, even cloud tensor processing units. Each framework has unique strengths.
How do they differ in practice?
TensorFlow, Google's framework, excels at large-scale deployment and production systems, perfect for our delay predictor handling 50,000 daily passengers. PyTorch, Facebook's framework, offers dynamic computation graphs ideal for research and experimentation, great for our evolving chatbot.
What about our image recognition system?
That uses Keras, a high-level API that runs on top of TensorFlow. Keras simplifies neural network development with Python, making complex image processing accessible. Each framework targets different developer needs and computational requirements.
So framework choice affects system capabilities and performance.
Absolutely. The ISTQB highlights that frameworks support different programming languages, processor types, and ease of use. TensorFlow optimizes for scalable deployment, PyTorch for flexible experimentation, scikit-learn for classical machine learning approaches.
This must impact how we test these systems.
Exactly. TensorFlow systems often require testing distributed processing and scalability. PyTorch systems need testing for dynamic model changes. Scikit-learn implementations focus on classical algorithm performance. Framework architecture shapes testing approach.
How does framework knowledge change our testing strategy at Aviation 360?
Dramatically. For TensorFlow systems, we test production scalability and GPU utilization. For PyTorch systems, we verify that dynamic model updates don't break functionality. For Keras systems, we test that high-level API abstractions work correctly with underlying engines.
And framework bugs could affect our AI system performance.
Precisely. Framework updates can introduce new behaviors, deprecated functions can break existing models, and framework-specific optimizations can cause unexpected results. Understanding the framework stack helps us identify whether issues stem from our code, the framework, or the underlying AI algorithms.
This adds a whole new dimension to AI system testing.
Next episode, we're diving into AI hardware, from CPUs to GPUs to specialized AI processors. You'll discover why the same AI model performs dramatically differently on different hardware and what this means for testing.
After learning about development frameworks, I'm really curious about the hardware that actually runs these AI systems.
The hardware revelation will completely change your perspective on AI performance. Subscribe to Testtactix for the complete ISTQB AI tester certification journey. We're building deep technical expertise